As shown in the figure, a strong magnet is held in front of an iron trolley based on smooth track. Discuss the state of motion and state any law you apply. Okay, so here we have the magnet and the metal trolley. So what happened when you hold this magnet in front of the trolley? Okay, so it can produce some forces definitely. So due to these, since these are magnet, this is magnet, so there may be some forces. Okay, but when you consider the whole system, so these forces are internal forces. So there is no net external forces. So the net external forces, so these are cancelled out. The net external forces act on this whole system is zero. So according to the Newton's first law of motion, this system should be in stationary because there is no the net, because net forces, net external forces is zero in this system. Because of the inertia, so there is no net non-zero force, so this one resists to change its state of rest. That is called, we can call, say, the inertia of the system. Two blocks, capital A and capital B, of mass 2 kg and 1 kg respectively, are in contact on frictionless table. When a horizontal force capital F is applied on capital A as shown in the figure, the force exerted by B on capital A is 1 Newton. Here the F1 is 1 Newton. If instead of the same force is applied to B in the opposite direction, find the force exerted by A on B. So they are to find this capital F2. Okay, and they are to draw the free body diagram. So these are the free body diagrams for each blocks. Okay, let's consider this one. So they say this F1 is equal to 1 Newton, and they ask you to find this F2 in this case. So how you draw the free body diagram? So when it is in a gravitational field, definitely there should be a weight of the gravitational force and the reaction from this surface. So it is R. Here also the mg and R2, equal and opposite forces. And when you push this block, so it produces definitely the action on the A and the reaction on B. Okay, here also the same thing. When there is a gravitational force, so the reaction is the weight is mg, and here also weight is mg, and the reaction force is R2 from the surface of this surface. And when you apply a force from this side, so that push these blocks. When it push this block, it produces some, when these two A and B are contact. So when these two are in contact, so it produces some reaction. So when there is a reaction force F2, so the action force should be definitely come. So it is F2 here. F2 is from B on A. This F2 is from A on B. Okay, so these are according to the Newton's third law of motion. Okay, we can easily calculate this one, or we can easily think about the F2. Okay, let's calculate it. So let's apply the Newton's second law of motion to the block B. For the block B, you can apply F is equal to mg. So rightwards. So the net force upon the B is F1. F1 is 1 Newton. Mass is 1 kilogram and the acceleration is unknown. So acceleration is 1 ms minus 2. Since the whole system is connected to each other, the whole system also travel with the same acceleration 1 ms minus 2. Only one external, non-zero external force is applied, it is F. So the same force is applied to other side on the same mass. So the same mass should be traveled with the same acceleration 1 ms minus 2. That means that this A also moving with the same acceleration 1 ms minus 2. Now we can apply Newton's second law to the capital A leftward. So F is equal to V. The net force applied on this one is F2. The mass of this one is 2 kilogram and the acceleration is again 1. So F2 is 2 Newton. Okay. We can generally say this one, so without writing any equation. So when we consider the F is equal to MA, and the block B, F1, A1, so the acceleration definitely should be 1. Since these two are 1, the acceleration is 1. Definitely, no need to apply the write any equations. And then if you want to 1 kilogram, accelerate 1 kilogram in 1 ms minus 2. If you want to 2 kilogram, accelerate again 1 ms minus 2, you have to apply 2 Newton. That is the simple logic. As shown in the figure, gravitation force acts on the child. Consider that force is action. Draw the reaction force and explain how you get that reaction force. Okay. So the gravitational force on the child, it is downwards. So that gravitational force is act on the child. So the earth pulls this child downwards. So that is, let's say, action. And this child pulls earth upward. So this is the reaction. Reaction on this case. So most of students think the normal force is reaction. That is not the reaction. So for this situation, the reaction is the child pulls the earth upward. That is the reactional force.